Oh, we get to talk about solving equations with Excel. So first we'll talk about Newton's method. We'll review Newton's method. So the intent is that we would be able to solve this equation right here, right there, so that looking for a value of x that satisfies this expression. Our function of x, remember we want to keep everything on the left side and the other side equaling 0, is this, and then our derivative is 3x squared minus 9.3. And Newton's method can help us solve that expression. And we have our new value of x equals our old value minus the ratio of the function value of the old value divided by and the derivative. So function divided by the derivative. So we'll just do that right here. So we'll start with a guess value of 10. And if we use that guess value, we can put in an equation for the guess value, x third minus 9x times x, which is that guess value, plus 2. So there's our function value, and here's our derivative value, which is just 3 times that 10 squared minus 9.3. And then the next value of x that's hopefully getting me closer to satisfying this equation is the x old, x10 there, minus the ratio of the function value and the derivative. And then I can just copy these down here. Just drag this, if I can get it to work, let's see. Yeah, right there, drag that down. And you can see my new values converge to like 9.357. So it's saying method 2 here, but this is much clearer than method 1, where you have all of the equation on one line, and you can do the same thing of copying that down. But that's the Newton's method review. Goal seek. Let's do a different equation. Here's one. We once again rearrange so f of x is equal to 0 when x is at the solution. And I can use goal seek, which goal seek is under tools and goal seek. There's a plot, so I have x values, and this is the f of x value. You can see it comes up here. It's like an inverted parabola. So if I start at 1, the derivative should kick me down over here to around 0.6 or so. So let's do that. So I've got my cell set up with x and then my function value here. So since it's 0, I'm at negative 9. So let's say sets our cell, we want this f of x value to equal 0, and we want to change this cell. We want to change x. So in this case, this is my starting case. This is my guess value, and it should just come up here to find it. So I can say OK, and it says it found a solution. So it's pretty close to 0, and it's around 0.643. So we could come from the other side too. Maybe we put this here at 1, and then go up here at tools and goal seek right here. And I can again specify this cell equaling 0 and change this cell right there. And it should find 0.64. Yeah, 644. You'd find another root if you had another value of 1.5, for instance, and then did the same thing. Tools, goal seek. And let's set our cell there, set it equal to 0, and changing this value there. And this is a derivative-based method as well. And you can see it finds a different root, that 1.86 root there. So that's goal seek. There's also something called the solver. This is a little more powerful. So in the last sheet, we just showed the first part of this. But here you can use solver. So here I've got 4 instead of 0. Like if I put this in, it's at negative 9 like it was in the other sheet. But yeah, we can use the solver, and it's also under tools is one way to get to it, the solver. And we can set our objective. So that's this guy, F right there. And I'm going to set him to a value of 0. And I'm going to change cells there. And yeah, good. I can add constraints. We'll talk about that in a minute. And there's different methods you can use. And yeah, there's some constraints there, but you say solve. And it says it found a solution. There's the 0.644 one that we found earlier. And you can change the guess value by just changing this one like we did. Like maybe we change it to 8. And it might find this value that's around 7.5. So yeah, there's that, and there's also a way to solve multiple equations. So I can rewrite this a couple of ways. So here's equation 1 and equation 2. I can also plot these. So here's equation 1 is, equation 2 is this 2x plus 3. It's a line. And then here's the other one that's a parabola. So I can solve for the values of x where the y values are the same, which is right here, and I can transpose that in this way, x1, x, and x2. So I have two variables there. It'll also solve the y values there. So I've just made it, instead of y's and x's, I've got x1 and x2. And I put everything on the same side, so I've got it 0. Method 1 is I use the solver. You can't use goal seek in this situation, but you can use the solver. And I can say set my objective. So here's some guess values, x1 and x2, and there's my function values. So I can set my objective so that f1 equals 0. And by changing the x1 variable and x2 variable, so I can highlight both of these. So I got both values there. Then I can add a constraint. So I want to add this constraint right here, that it is equal to 0. And I can add that. Say OK. I think I added it already, so it's right there. And then make unconstrained variables non-negative. No, I don't necessarily need that. And I'm going to solve. Solver found a solution. So it says keep solver solution. OK. So I've got negative 1.61 for right around in here. And the second value is negative the x2 is the y value. So the y value here is, it's found this solution right here. So it's got negative 0.2. That's the y value for x2. And the function values are really close to 0. So you could set that up to find this solution as well by just changing the guess values. And another method is, instead, we can change this. So let's just change it to find the other one. So x1 is 2, let's say, and y is around 2 as well. And so I am going to do instead this method where I sum the errors. So instead of doing the second equation sub being the constraint, that second f value, I'm just going to sum up the errors. So this one, 10 minus 0, is the sum of the squared error because I want it to be at 0. And then I square it, so that's 100. And then this one should be at 0. 5 minus 0 squared, that's an error. And then I'm going to sum those two. And then I'm going to come up here and go Tools, Solver, and instead of, I'll set my objective of the sum, and I want to minimize that sum. So I want to minimize the sum of squared errors by changing those same variables. And I don't need my constraint anymore, and I can solve that. And it found it. So in this case, where x1 is 0.6, right there, where those two intersect, and my y value is 4.23, so it's found this solution by minimizing the sum of the squared errors. This is really important. The principle you understand is, and this is used all over the place. So you can solve multiple equations by minimizing the sum of the squared errors. And we'll talk about that more in regression. But here's some practice problems where you can solve three equations with three unknowns using the solver in a similar way. Great talking to you. God lives and loves us.